Okay. Okay, it's recording. I will share with you later on, Dr. Hana. Okay. I stop my sharing screen first. Later on, President can update me what is the issue on your Mozilla. Okay, what I want to share now is my third slide where you can download from the website. Okay, for my third slide, okay, I have the last part to share with you on ANN. Okay, hopefully everyone can see the code. Okay, so this is my coding slide. Okay, just to share again. So in general, we are not doing anything on unsupervised learning today. We don't do this one. Okay, what unsupervised learning, you can imagine like a clustering technique. So anyone heard about KNN, for instance? Okay, this is roughly like, okay, right, Waylun. It's work for your side, Waylun? Okay, so the next one, semi-supervised learning. This is where when your data set is very expensive, the label data set is very expensive. So we can have a combination, semi-supervised, supervised and unsupervised learning. Okay, so then we talk about reinforcement learning. This is very good for those who are working on robotics, okay, which is we not covered today. And the last part that we are interested for today, just to re-highlight again, supervised learning. We come with a label. What is label again? In our case, we have apple and orange. The latest one, we have a Pima Indians. Label 1 and 0. Alright, so this is again our slide. So at least just to refresh you again untuk perceptron. So hopefully ingatlah perceptron ni macam gini lah perceptron work. Combination of perceptron mewujudkan MLP or ANN. So this is a simple calculations with the sigmoid functions. Okay, another example on calculations. Okay, so this is how your neural network looks like with the two hidden layers. Okay, what we interested on now from the basic, from the understanding on ANN, kita nak gunakan keras TensorFlow to develop our ANN in Google Colab. Okay, keras is a powerful and easy to use Python library for developing the model. It wraps the efficient numerical computations. Libraries Tiano and TensorFlow and allows you to define trained neural network model in few short line of codes. Okay, so hopefully everyone can see. Okay, first, of course, in my code later on, because this is last time mainly on the Python code. So this is a important package that we need to include in our ANN development. Okay, I will give in detail later on, but as simple as sequential, our layer is adding up layer by layer. Dense, okay, for today class, okay, don't confuse. I just want to share with you, we are talking about fully connected layers in terms of the configuration. So that's why we need to have the dense. And then this is all some of the package and numpy random.seed. Okay, in general, our weight earlier is going to be randomly initialized. So random seed, we're trying to start with some pseudo random number generator. So every time you run with a seed 7, it always begin with the same numbers in terms of the weight value. For all the weight value, firstly, we need to randomly initialize. By defining this one, your initial value every time you run the code will be the same for all weights that available in your configuration. So hopefully it makes sense. Okay, so the next part is we want to load the data. So this is where we trying to load the data. Okay, so again, for Pima Indian dataset, we have 768, 8 class. The last one is our label. So we include import IO, okay, just to access input and output. And then we formatting the data, and in order to read from the CSV, we use a pandas. Okay, you can Google what is a pandas. This is like a library, okay, that handling the data in a frame. Okay, so when we have the data, a variable called sample df. Betul, bukan food panda Okay, and then kita ada kita punya code kat sini, dataset values. Okay, this is your X, this is your feature. Remember on orange and texture, orange and apple problem, we have our features a C and C and T, a texture. So in this case, we have all these 8. So this is referred to the X. And Y is your label. Okay. I just want to go through next. Okay, then we need to define the model. So this is the model. Okay, we're going through again, hands-on all these things. So we have a sequential. Why we have 8? Because we have 8 input or 8 features. So why we have, okay, don't care about the others number first. Why we have 1? We just want to differentiate between diabetic and non-diabetic. Okay. So what this 12 and what this 8? Okay, so in this particular example, what we're trying to do here is we are designing a network like 1, 2, 3, 4, 5, 6, 7, 8. So this is my 8 input. Okay, clear, right? So this is my 8 input. So anyway, I have 2 hidden layer in this example. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is my first hidden layer, followed by another 8. So I have 1, 2, 3, 4, 5, 6, 7, 8, right? And the last one, I have only one output node. Okay, get the idea, right? So I have 2 hidden layer, and this is my only output node, and with 8 input nodes because of 8 features. So then again, you have your perceptron. Combination of perceptron make your ENN architecture. Okay, so I think number 12 I addressed, number 8 you know. Okay, what is ReLU? Okay, activation function. If you see my example just now, my activation function can be like this one. I can have something like a sigmoid. Okay, what is ReLU? ReLU is much simpler. ReLU is basically just like a simple threshold that I draw here. So how it works? So it just functions of y equal to max 0x. So anything smaller than 0. So for instance, if I have dia pening sikit sini. Okay, max. Okay, just a very simple function. Max the ANN can speed up. 0x, let's say my x is 5. What is max 0x and max 0.5? It gives me 5. So what happens if I have max 0 minus 2? It gives me 0. So in general, it's similar to this one. Okay, so anything smaller than 0, okay, smaller than 0, it only falls to be a 0. So non-firing. Anything smaller than 0, don't fire. So this is how the perceptron works. So this is how we interpret all this value here. So this is our max ReLU, max function, and sigmoid we have, as I mentioned here, 1 over 1 plus e power of minus z, if you still remember. So this is again to firing or not to firing. Okay. Next, we move to, this is how it looks like. Okay. 8 input, output layer, hidden layer, hidden layer. So 2 hidden layer with 12 nodes, the next hidden layer with 8 nodes, and the output layer with 1 node.
Dr. Ibrahim, ni ada soalan tanya. How do we know that this going to be 2 hidden layers? Is it going to be example in this exercise, or do you have selections, nak buat 12 saja ke ataupun 12 dengan 8 ke?
Okay. Seperti saya maklumkan, terima kasih Dr. Latif. So saya maklumkan tadi, yang betul-betul kita kena define cuma input dengan output node saja. So your hidden layer, berapa hidden layer is up to you. Berapa hidden nodes is up to you. Okay. So it doesn't matter. It is a matter, but it depends on the experience. So tomorrow when we start on CNN, you will see my hidden layer can be extend up to 10 layers. Okay, at least let me answer you correctly. Input and output nodes, it depends on your input numbers of features. Output node depends on number of class or digit that you need. But hidden layer and hidden node, it based on the expert and the designer later on. We need to keep changing this value until we make the model as good as possible. So jawapannya, it can be any value. There's no simple rule of thumb on this one. Sorry, Mac 0x, how to define the value of x in Python? How to define the value of x in Python? Okay, you just put x equal to 2, for instance. Okay, later on when in collab, hopefully Bukhari boleh share, boleh refine saya. Bukhari boleh highlight saya. Okay. Okay, close first. Okay, what we want to do now, okay, after we load data, we define model, now we want to compile the model. Okay, what it means by compile the model? Okay, I'm trying to have a look on the WhatsApp as well as I stop now. Ramai yang belum connect drive data. Oh, okay, okay. Please do while I'm sharing on the slide. We focus on the presentation as well. Okay, alright. Maksud sigmoid. Okay, maksud sigmoid tu saya share balik. Sigmoid tu activation function. Yang kita, kalau kita ingat tadi, saya draw balik saya recall balik my perceptron y equal to f, okay, the functions of net, if you still remember, right? So this is my f net. So sigmoid is one of the activation function, one of the f. ReLU is one of the f. So y equal to f net. So what is net? Net is given by your input times your weight plus x2 times your weight plus, if you have more than, so in this case I have only 2 inputs. For instance, on Prima Indian, I'm going to extend up to x8 times w8. So this is my net. Okay, let me relate back. So how it looks like. So I have, for example, up to 10 here, up to 8 here. Then I connect to one particular nodes on the sequence, the next sequence layer. So this is my perceptron. Just to recall again. Right. So this is all the 8 here. So where is your x1? This is your x1. This is your x2. This is your x8, for instance. So this is your w1. This is your w2. This is your w8. So all these things apply into as a net. So sigmoid is activation function. So how it looks like. So now I can write my y, as I know my f is a sigmoid. I need to write 1 over 1 plus exponent of minus net. Hopefully you get the idea. So this is a sigmoid function. How it looks like? It looks like this one. Hopefully I can draw nicer lah. Okay. Okay, this is like this one. Where ReLU, it has a sharp changes. Okay, but sigmoid don't. There's a asymptotic of 0 value and asymptotic of 1 value here. Right? So this is my sigmoid. So what is sigmoid? Sigmoid is this function. Okay. Alright. Hopefully it answer you. Okay, output net, yes, Dr. Latif. Output net depend as input not depend on the features, yes. Okay, for the others kalau tu maknanya macam Dr. Latif cakap lah, input dan output tu bergantung kepada bilangan features dan bilangan kelas yang kita perlukan. Okay, now we move to load. and then we define. Now we move to compile data. We want to compile data. So kita dah ada network sekarang tadi. So mari dekat define model tadi tu kita dah ada roughly how our configuration looks like. Ingat kita kena tahu dulu macam mana network kita looks like. So in our case we have 8 and then we have 12 here. And then I have another 8. And then I have 1 only here. So this is my where it defined model trying to do. So this is my defined model. So what I want to do now, I want to have my loss function. I think before the lunch break, someone asked me about what is the best loss function. Okay, as now we are solving 2-class problem. So we're going to use a binary cross entropy. Okay, and Adam is basically the one that we not cover. That's why I shared here. I want to cover some part of the back propagation. So this is where Adam, it is a gradient descent where we want to go forward, backward. Again, the objective is what? To make sure my actual and predict are the same. My predict and my actual to be the same. So if my predict and actual to be the same, I need to do forward and backward. Okay, so the backward part is allow the network to keep change the W. So you can imagine right now, all these have the W value. So all these W value need to be updated. Okay, so this is where the back propagation comes in. You go forward, okay, applying all the necessary things, and then go backward with the given loss function, which is my binary cross entropy. So Adam here is one of the algorithm to do gradient descent to get the gradient of the error, where it allows me to update the W here. Okay, if you still remember, I think I have the W new plus W new equal to, okay, W new, okay, equal to my WO plus the gradient change of my W new. Okay, so this is the term that can be solved using Adam here. So this is where we're going to get always a new W, where it allows me to keep changing in the backward directions and go again on the forward, where towards the end, we want to make sure our predict and our label are the same. Predict equal to actual. Hopefully, at least we can keep in your mind. ANN is about labels given where my predicted value from my ANN to be the same as my actual. All right, so this is the purpose of my compile model. I just define. I don't do training yet, but I want to define parameters before for the compilations. So this is a loss function. It's called logarithmic loss for binary. If you still remember my loss function, L equal to, right, minus Y log Y hat. As simple as Y is my actual, Y hat is my predicted value P. Hopefully get some idea on this one. So this is my actual. And this is my predict. So if you still remember how it works, we want to make sure this Y hat always the same as Y. So my Y can be only 1 or 0. So this is where I have my Y. Okay, if you still remember, I have 1 minus Y. Okay, times log 1 minus Y hat. So it's going to be a 0 whenever my Y equal to Y hat. Okay, so we define the loss function and the optimizer, a gradient descent here. So we want to get the classification accuracy. Okay, hopefully you can ask any question from the WhatsApp. I just proceed to the train model. So this is the code. Okay, later on we'll see. So I want to share a few things here. Model fit XY, you just pass the data, all the data to do the training. How many iteration we want, how many epoch? I trying to differentiate now. What epoch? First, I just make it a general statement. Epoch is an iteration. But because of sometimes we have a limited resources, we need to have a batch size of the data. Okay, let me give you an idea. For instance, our data set now, I have 768 data set, right? Samples. On Apple, earlier in the morning, I have 100 sample of fruits. 768 means is the whole patients that coming to John Hopkins Hospital and been assessed by the medical doctor whether they have a diabetic or not diabetic with a true clinical test. So let's me relate on batch size and epoch now. Okay, so if you have 768, so now you can imagine I have 768. So let's say this is whole my data set. So 768. So what I need to do now, a batch size of 10. So I'm going to chunk it into 10, 10, 10, 10, or 10, 10, 10, 10, until I have up to 776, 77. So this is my first 10, my second 10, my third 10, fourth 10, and until the 7710. Because 77 times 10 is 770. That's the closer integer number. So why we need this one? Sometime when our data set is too big, our memory in GPU or CPU tak cukup, tak muat. So that's why kita kena batchkan dia. Sorry. Kita kena batchkan dia. So here I can define two keywords, two important keywords. So for this particular example, with 768, I have 77 block. So in general, what I want to share with you, one epoch of this particular example, one epoch equal to 77 iterations. Get the idea, right? Both are iteration, but one epoch cover the whole training data set. But one iteration only cover one particular batch. So that means if I have a second epoch, they will use the whole 77 iteration again. So in general, if I have 150 epoch, okay, epoch here, so I'm going to have a numbers of 150, okay, sorry, 150 times 77. That's the total number of iterations. Loop inside of the loop. Okay, so hopefully you get an idea. So this is how we going to, so in the keyword, the function call in this particular Keras framework is called feed to do the training. Okay, let's move to the next one. Okay, so this is a number of total iteration, number of instances, batch size. So this is the idea. Okay, next. Okay, so this is where we're trying to split the data set. So if I want to share here, this is what we're going to do now after this. So this is allow me to have 33%. So from 768, as simple as 67% and 33%. This is my train. And I keep the another 33% of the data set, 33%, okay, 67% from 768. 7 times 7, roughly 400 plus. Okay. And 30 times 7 is around 200 plus. So this is where we partition. So now you can see your data set from the 768. So I put aside, this is for training. This is for my validations. So in total, I have my 768 data set. Do you get an idea, right? Okay, so same thing. All right. Move to the next slide. Okay, split. Then we will see we're going to have the metrics
Dr.
on
Ibrahim ada
soalan
higher epoch value and smaller batch size will result better predicted data.
Okay, let me answer on the epoch. Again, if you still remember on overfitting, if our data set is not well in when we screening the data set, longer epoch may end up with a good model, but it may introduce overfitting. But again, normally longer epoch is good to improve the performance of the training accuracy for sure. But in terms of overfitting, it depends on your data selection. But simple to say, longer epoch good in training, and normally it's good as well for the whole idea of the model where it's ready to do the validation. Okay, batch size is nothing so much to do with the accuracy, but it mean to do with your memory consumptions. Later on you will see, but maybe for this tomorrow, I think when we do some detection, the size of image will tell you how slow and how fast the throughput of the network. Okay, so in summary, epoch is good for your training accuracy. Batch size nothing to do with your performance, but in terms of the performance of accuracy, but it's good for your memory consumptions. Normally kalau kita punya card kecil, GPU size of the memory terlalu kecil, we need to control this batch size. So tomorrow I think we have
Okay,
some.
another one.
Okay.
Regarding the percentage of the validation data set, some of the examples of the database that you showed earlier, we have like say 60,000 of data, 50,000 are being used for train, and then another 10,000 for the validation, right? For this example, we have 67 and 33%. So what will be the values, the best or optimum values for the percentage of data for train and data for validation?
Okay, thank you, Dr. So there's no. Okay, first let me respond in two ways. MNIST dataset by default they already put into that way, training and testing. So but I change it into validation. It's available. So it's just a dataset by MNIST, 60,000 plus 10,000. But normally people use the rule of like this way. They can go to 60, 20, 20, 20. Okay, what is this 20? So this is my train. So you can imagine like I have all my data set. I purposely put this like a tomorrow data set. Okay, tomorrow data set, which is I completely didn't know at all about this data set, just to evaluate later on my performance. So this is 60%, this is 20%, same thing, 2020. So this is my validation, this is my testing. So but again, this completely you put in separate directory. You only use after you confidence on your data set. You assume this is like tomorrow data set. And another approach, sometimes people are using the idea of 70%, 30%. Okay, so again, that's why some part of AI they are still uh, have the gray area. They call art part of the AI, but this is in simple word, they have the problems on the variance. Okay, and the error part. Okay, so this is where we need to have three important factor. I think always remind we need to have large data set that cover the whole population of our problem. So for instance, let's say we are talking about apple and orange. If possible, we try to cover the whole population of apple and orange, which is impossible. But again, as long you can make sure all type of apple that have different shape can be considered into your sampling is good enough. So large data set will work, plus a good algo. So again, there is no direct answer on this one. plus the computation, so remember. So this is give a good AI. So, and these two normally is compensating each other. Okay. All right. So let me respond again. So for MNIST dataset, 60K and 10K is defined by the owner of the dataset. First rule apply. So this is the first rule. First rule apply 60-20-20. The second rule apply 70-30. Okay. So again, it's up to the designer later on. That's why we need to have a good computer machines. Because let's say you try on the first rule, it takes you 1 day to complete this one. It's a 1 day machine, 1 day machine, 1 day. So if you apply a second rule, you need to wait another 1 day. So good computation from 1 day, maybe you just need 4 hours. And then instead of running 2 days, you just need to run only for 8 hours. Alright, so hopefully it answer. Kalau ada lagi boleh ni. Okay, so now we have our train and then we want to train 60-70. Okay, this is all the train. You can have a look. Okay, we don't go in detail about how we do the k-fold cross validation. I think I just give an idea how the cross validation, k-fold cross validation works. So let's say I have my data set here. Okay. So what I'm trying to do now, I need to sample the first part. I just take 70. This is my first 70. And the remaining is my 30. So this is I call a set one. So this is good on the statistical point of view because we want to understand the worst case scenario of our model when we apply K for cross validation. Let's say the same data set, I draw here again. Okay. So the way I select the data set now, I also take a 70 but from different data set. So now this is my 70 and this is my 30. So I call this as a set B. Sorry, set 2. So if you do again and again, you're going to have like certain combinations of that. Okay, so in this case, we use 10. So from each of these, we want to know what is the validation performance of this data set. So maybe I can have something like this one. So this is my first model. So this is my second model. So I just want to see the consistency or the worst case scenario of the model. So if I have a 10, so I'm going to have 10 loss function on the cross validation. So from this one, I can understand when my model start to not working well and what is the best condition that my model can offer. All right, so this is about the K-fold cross validation. It is more on the statistic. If we have a time, we're going to try on this one. But at least I want to share with you. This is more on how we're going to do a lot of tuning later on. And the last one, we want to evaluate. We evaluate the model and we want to get the score accuracy. All right, so let's go back to a code. Okay, hopefully when I finish my Pima Indians, we can have a short break. But let's move to our Pima. Okay, because we take some time, so I need to run again. Okay, it finish the session. Let me check. Oh, it's okay, it's fine. Okay, semua orang ada ni ke? Ada soalan ke? Kalau nak tanya, saya tunggu. Ada soalan? Okay. Epoch equal to 150 iteration will take how long? There's no definite answer. Let's say we are applying a Pima Indian. Maybe the size of the whole data set is, you can go and let's have a look. What is the size of the data set? It's not here. Let's see if I refresh. Okay, but I have the file. Let me check on the Pima Indian dataset. what is the size of the image, size of the dataset. For PIMA, it's just 23 kilobyte. Okay, so 150 for PIMA Indians and 150 for MNIS may different because your size of dataset is already different. Okay, so we're going to run and see. Okay, let's have a look. So hopefully it answer. There is no definite answer on this one. It depends on number of dataset, number of network, the size of your network, the big. I mean, if your network is very large, maybe 150 iteration can take 1 day. So for instance, we try earlier on the image dataset. We download. It is around 128.
Dr. Ibrahim, your screen tak nampak lah. Are you
Okay,
sharing
nampak ke?
something?
Sorry. Sekarang nampak ke? Oh, okay. Betul-betul. Saya on the slide. Okay, saya kena tukar balik. Maaf ya. Okay, let me share on the code now. Okay, nampak kan?
Belum lagi. Kejap Okay, dah nampak dah.
Okay, sorry. Okay, tadi saya jawab soalan daripada Dr. Wan tadi saya rasa. Okay, so 150 will be different, depend on your network and depend on your data size. Okay, now we want to do all the things that we have discussed earlier. So hopefully everyone already mount. Kalau ada masalah, tolong maklumkan ya. And then this is where our data set, we can access the data set now. Okay, so next what we want to do now, we want to get, okay, welcome. Okay, so this is where I have my PIMA Indian data set. I also have a few places in my G drive on my data set. Please make sure you access the right, okay, hold on. Otherwise I need to do it again. Okay, so please make sure you access on the right path. Okay, so this is where I call the CSV dataset. Okay, from my data. So you can run. Okay, import first, import IO and import pandas SPD. So those who are new for Python, import pandas SPD. I just want to shorten my pandas into PD. Okay, now I want to call the data set from my Google Drive into the variable called sample df. So this is my data set called sample df. So if I run, so this is all my data set, okay, that I have. So again, I can draw here. So this is my feature number 1, feature 1, feature 2, feature 3, feature 4, feature 5, feature 6, feature 7, feature 8. And this is all my class. My label, apple and orange, 0 and 1. Hopefully you get the idea, right? So this is my data set. So again, I just want to extract the data set. So you can have a look. Okay, you just run this one. You do not know how the X looks like. So you can print the data set, print X. So this is my data set looks like. So if you see here, 185, 185, 66. Okay. So then if you want to see on your Y, it's just 0 and 1. So again, this is my label. This is my label. This is my features. So you can put some comment in your code. This is my features. This is my label. Okay. Hopefully we can move to the next one. Okay, now we import all the necessary things. Okay. And then we try. Okay, hopefully you get the idea. The sequential is for neural network to adding network sequentially. And then dense is for the fully connected layers. This is again, I use pandas just now. but of course it's already you can remove this one, no issue. And then we trying to do utilizing some of the utilization of the keras. Sklearn is very good. If you want to have a look, you can go and Google Sklearn. It's mainly for machine learning. NumPy is to deal with a matrix, and keras callback to do some plotting later on. And this is for plotting as a figure. So this is where I trying to randomize the weight value. Okay, so this is where we want to convert integers into dummy variable, one hot and cold. So let's have a look my network.
Okay, Dr. Ibrahim, apa ni, some of the original file, the drive is not directly under data, right? So it refers
Yes.
to your ANN, apa tu, some folder. So untuk the second one, can you go back up? Okay, so we have the first one, ls, just to check whether our file is inside the drive or not. The second one, number 8 there.
Okay.
So number 8 there, content drive, my drive, collect notebook, data, my index, diabetes.csv. Semua dapat ke yang ini?
Okay.
Because saya tak dapat. Sekejap saya try balik sekali.
Okay. Kalau Dr. Atin nak share screen pun boleh. Jadi
Okay.
saya stop dulu. Jadi semua orang boleh dapat yang sama. That's the purpose.
Okay, nampak?
Boleh besarkan ke?
Okay, ya. So currently, ni dah keluar. So this one, I tadi copy balik. Content, drive, my drive, collect notebook, data, my index, database CSV. Tapi keluar error.
Okay, I think Dr. Atif, kita tak if I may, Dr. Atif, I request to annotate to you. Boleh accept tak?
Dah, okay.
Okay. So let's run this code because they mention name PD is not defined yet.
Oh, okay. So kita tak run lagi ni.
I think the pass is already correct. Okay. Hopefully it works. Okay. Dah boleh move to the next one. Can skip to 11. Okay, run. Okay, it's working now. So
Okay, dah
just
okay.
dah okay. Cuba klik yang the next one. Dr. Atif.
Okay.
Okay, run.
Okay, keluar dah.
Okay. Okay, I take my sharing there.
Okay, so saya punya masalah tadi adalah maybe I didn't run this import IO and import panda as PB, so dia tak refer this file.
Yeah. So that means library tu belum available lagi untuk dipakai. Okay. Okay,
So
I
have some similar problems. Maybe you can check your sequence.
yeah. We check as sometimes I also miss most of the time because it's a cell based. It's not like a Python. Python is just like you dump all the codes and run and compile and run. Jupyter is cell based. Okay. Let's move to the next one. Okay, so kalau ada soalan boleh tanya. Okay, kalau Dr. Azlan nak share on your screen pun saya okay. Kita work together. Dr. Azlan boleh share screen? Oh, ramai belum dapat. Okay, saya tunggu semua orang. Satu-satu pun tak apa. Saya just nak make sure at least semua orang boleh run on Tima Indian. And then you can do on your own, for sure. Okay, boleh dulu ke kalau Dr. Azlan don't mind to share your screen? Kita tengok, kita cuba debug sama.
Okay, siapa yang tak dapat lagi, you are stuck dekat mana? Adakah dekat daripada database lagi?
Oh, screen tak boleh share ah?
Oh, screen tak boleh share ke? Okay. Okay, anyone yang boleh share screen, kalau don't mind to share, at least we go together.
Ada siapa-siapa yang nak share screen ke?
Dia beritahu apa? Webex tak boleh share screen, dia cakap apa? Mungkin saya boleh allow ke? Okay, it's okay. Let me do again. We're going to spend some times here untuk kita bolehkan semua orang boleh run. Saya share dulu my code. Okay, kita lihat balik daripada awal. Okay, mount saya assume semua orang dah boleh mount Kalau tak boleh just share je. Even you can personally WhatsApp me. I'm fine. Okay, mount this one and then this is where kita nak tengok apa yang ada dalam drive kita. So dalam drive kita ada drive tu sendirilah, content drive. So okay, kalau saya run kat sini, sebenarnya kalau kita tengok dekat sini, okay. Tadi ada orang nak cuba share tadi saya rasa.
Nak cuba share tapi tak boleh
Oh, tak boleh Kalau screenshot letak dalam WhatsApp possible ke?
Okay, kejap try.
Okay. Okay, kalau kita lihat dekat sini, kalau kita nak tengok sebenarnya apa yang ada dalam kita punya My Drive, sebenarnya is content of all, depends on, depends on what you have in your drive. Okay, so in my case, I have a lot of folder and file. So this is what we want to access. Okay, let me see. Okay, I just trying to have a look. Okay, file not found error. Okay, can the way we want to do. Okay, now everyone can see my slide. So this is the idea. Can Dr. Azlan, can you just run? I'm afraid more on the. Saya takut dia punya ni path je, not back, not book collab. Okay, in my case, collab notebook. Sorry, collab notebooks. Collab notebooks. Okay, so in my case, I have collab notebooks. Okay, boleh tak run yang ini? And then nak run ls exactly same like this one. If you can share on the WhatsApp pun okay. So I just want to make sure memang path tu wujud. Kalau tak ada nanti dia akan give error.
Oh, tadi dah boleh access ni, tak ada pula content dia. Sekejap, saya tengok sekejap.
Okay. Sebab collab betul dah betul lah ni. Saya rasa semua orang standard macam gini sekarang. On data. Okay, kita try dulu tengok. Most probably macam tak ada file tu. Okay, tak apa, kita spend time sikit sampai semua orang boleh run. Okay, at least objektif today kita habis satu neural network for Pima Indians. Okay, this is working, right, Dr. Izwan? Okay, kita tengok dulu. They're trying to solve. Dr. Azlan tengok apa isu dia. Okay, great. Dr. Izwan. Okay, kita cuba juga yang lain. Saya just nak make sure semua orang boleh run. So, this is where you can even use your collab. Later on, if you want to train everything, just use the collab and then bring your network later on. Last time I did some classification on Raspberry Pi. Okay, train everything and get the model. Later on, I share with you how we can save the model in the call .hdf5 .h5. So this h5 you can serialize into any platform. But not recommended for detection problem lah, unless you use really GPU like small embedded like Jetson. Okay, dapat ke? Okay, alright. Alright, okay, Presiden punya okay. Tadi isu dia apa yang Firefox tu? Dah boleh Okay. ANN data. Okay, alright. ANN data. Okay, alright. So ada iris betul. Okay, betul. This is great. Okay. Okay, saya very interested kalau Dr. Azlan boleh share ke? Saya rasa most probably takut data tu tak ada kat situ. Most probably lah. Okay.
Saya tak boleh access dah dia punya apa ni content dengan drive tu. My drive pun tak ada dah dia punya. Tapi bila buka dekat
Google Drive.
Google Drive tu ada. Dia data
Okay.
is there.
Most probably kena re-establish bila session terputus sometime dia akan if tak apa. Kalau dia terputus maknanya what is appear dekat sini Dr. Azlan dekat sini mounted at content drive ni keluar tak?
Tak. Dia tak keluar langsung.
Maknanya dia dah terputus lah tu saya rasa.
Okay.
You have to run this one again. That's why dia tak boleh jumpa data tu.
Okay, dah try. Tak apa. Doktor carry on dulu. Nanti saya cuba yang ni.
Okay. So in general dia macam seolah-olah kita tercabut pendrive kita tak perasan. And then kita tak boleh access data tu. Okay. So this is my data. Okay, kita move dulu sedikit. Okay. So this is all the library. Okay, for this particular example, I'm going to introduce one hot encoding. So this is the one hot encoding. So if I allow, okay, if you want to test also can. What you can do, okay, everyone so if you already run up to here, you can simply add code. Okay, click add code, right? And then print one hot Y. Okay, so this is the idea. If you see, this is what I mentioned to you, one hot encoding. So the first class, if I print one hot, okay, I just create another one. I print Y only. Okay, Y is not defined. I think capital Y will do. So the first one is a 0. Second one is a 1. So this is where 0 is equivalent to 1 0 is a 0. 1 0 is 0. So this is my 0 in one hot encoding. This is my 0. This is my 1. This is my 0. This is my 0. This is my 1. This is my 0. So this is where my one hot encoding. So you can imagine now, the one hot encoding here means my output layer now have a 2 output. Okay, 2 nodes. Okay, with the network architecture here, with the given of 8 input nodes. 5, 6, 7, 8. So this is the idea. So this is where my one hot encoding introduced in my code. Okay, next. Okay, I just want to share with you. This is I just want to make sure we call the information while we are running. Okay, so that's why I call loss history. I just a call back. So this is one function supported by Keras. Whenever they run, then I can have recording every epoch accuracy and loss for validation and also for training. Yeah, we share with you. Okay, so this is where we create a model. Okay, so again, we redefine again, numpy random. So this is not necessary. You can delete, it's okay. So let's see. So this is allow me to have a sequential network. And this is where I add, I think I already mentioned to you, 8 input in input layer and 12 nodes for the first hidden layer. So what I do now, so the second, now I have another hidden layer with 8 nodes. And last layer is my output layer with with two nodes by applying one hot encoding. So and then of course here we have different different activation functions. So now we want to create a model. Just run. So now I have a variable called a model. So the model consists the configuration of my network with one input layer, two hidden layer, and one output layer with the corresponding numbers of nodes. So I just want to run this one. History, loss history. Okay, so again, I think remember we use a loss function called binary cross entropy gradient descent, and this is where we run. Okay, now I add 1000. Let's run. Siapa dah sampai sini, kalau nanti saya akan tunggu, at least everyone can finish, must finish PIMA Indians. So this is how we utilize resources from Colab to run the training. So this is what you call a training. So they go forward and backward, forward and backward. So what you will see here, I have my accuracy, my loss accuracy. So now my accuracy is reaching up to, because my batch size, so you see some changes. Okay. So this is now I can see my performance of model. I am very confident at 70%, 60% accuracy. So it takes some time. So hopefully answer Dr. One question. So this is small data set. You can imagine 1000 epoch for 768 samples. It also takes some time. So it just now 400 is around 1/3. So let's see on the training. While doing this, please complete your code. If you are having problem, boleh WhatsApp saya ataupun share je dalam group.
Untuk module summary tu kita kena tunggu dulu sebelum kita selesaikan
Betul. Tapi boleh je kita run. Dia terus sebab this is not the dynamic. This just kalau kita tengok dekat situ dia refer kepada create model kita ni. Once kita dah create model ni dia dah boleh print out. Boleh run je. Dia akan beritahu kita number of layer. Tapi as it is after the epoch tu dia akan tunggulah daripada after the previous cell selesai. Okay, mine 600. Okay. So kalau nak cepat nanti kita boleh set je. Okay, so my performance now consistently at 77% accuracy. So maknanya daripada 768, 77% label predict dengan actual tu dah betul. Okay, in other words, Okay, maknanya kalau kita tengok dekat sini, so kalau saya boleh share dekat sini, so katalah 75%. So kalau saya ada sample predict, the actual label, and this is my predict. So whenever they predict 1, my predict is also 1. When they predict 0, I also predict 0. And there are still some error. So if they give it's supposed to be 0, I predict as 1. So this is if 75%, you can imagine like this one in general. So 3/4. Okay, so regardless, third of uh, 3/4 of the information is correctly predicted. Okay, so this is the idea. So okay, it finished. Okay, about to finish. Okay, so the total is, my model is having 78.75. It's around 78%. Okay, I don't tune anything yet first. Okay, so this is the network. Okay, what it means by 108 here, very simple. Everything we can understand in terms of the value here. So it means here I have 12, input saya 8 kan, features. Okay, 8 kali 12. Okay, this is the total weight that I have, plus plus 12. Okay, because I have a 12 nodes. Okay, 12 nodes. So this is my bias. Okay, let me draw after this. So if you do this one, 8 kali 12, 96. 96 tambah 10, 106, tambah 2, 108. So this is equivalent to 108. What it means? It means I have 1, 2, 3, 4, 5, 6, 7, 8. And then I have 12 hidden nodes on the next layer. So all these thing, okay, if you see here 1, kita ada 8 sambung ke first node daripada 12 ni. So 8 sampai yang ke 12 kita ada total 96. So all of these have one particular bias. B kalau you masih ingat. Okay, so kita ada bias. So it means kita ada 108 value yang perlu diupdate for this particular layer. So 108 weight, 96 weight tambah 12 bias. So what it mean by 104? 104 mean this is 12 connected to my 8. 1, 2, 3, 4, 5, 6, 7, 8. So ada 12, satu kali ni ada all are 12. 12 times 8 plus 8. 12 plus 12 times 8 plus 8. So I believe if you calculate, you get 104. Same thing applies here. Why we have 18? Because we have 8 dekat sini. 8 kali output ada 2. 8 kali 2, 16. Tambah 2 bias, saya dapat 18. So how many weight we need to determine in this network? 108 tambah 104 tambah 18. That's the total trainable weight. Okay, if you add all, you get 230. Okay, so hopefully it gives some idea. We go forward and backward. And then this is the time we want to test the network. So I take the first sample. Okay, so I want to print what is the value. So print class, oh sorry. So the first one, predict as, okay, let's say I choose the third one. So you can refer to the third one. So it gives me a class of 1. So, okay, I just want to share on the plot first. Okay, so this is where, okay, this is a validation accuracy. Okay, we don't have here. Okay, hold on, just want to get some plotting on this one. Yes, I have some prepared code for this one. Okay, so this is the performance. If you see on the train, okay, on the train loss and train accuracy. So my accuracy is goes close to 78% here. So this is my 78%, close to 1, which is 0.78, and this is my loss, very small value, close to 0.0000 something value. Ada soalan ke? Okey, boleh kita break.
Kalau graf
Macam mana Dr. Teh?
graf saya tak keluar,
Oh, graf tak keluar ya?
cuba share screen
Boleh? Can you scroll down? Okay, button. Oh, okay. Okay, okay, scroll down. If you see on the question 2, let me share the code, what you can write. Okay, I share on the WhatsApp group. You copy the code and then run, put into question 2. Okay, okay, Dr. Zaliha, what you can do, we need to see, please make sure you already call this one. Okay, I trying to stop in 5 minutes before we continue. Okay, let me share with you. So, datatifnya dah keluar ya, saya rasa. Okay, so now, what you can, please make sure you run this code. I'm afraid we are not running this code yet. For Dr. Zaliha mungkin. Okay, so this is where we capture the training process, the performance in every epoch, this particular line. Okay, so, all right, it's okay. I trying to finish up to here. To this one, okay, yeah, validation accuracy sebab kita memang tak ada validation punya data sebab kita tak split dia. Okay, I stop here, then I re-continue again after this. Can we break for 10 minutes if possible?
boleh.
Boleh So kita, okay, you all digest dulu and then kita akan relook again on the Premier Indian and then I'm going to start on MNIS. Okay, tak apa. Okay, doktor.
Hello. Yeah.
saja bagi cepat 45 dia dah boleh dah hantar mesej. Jadi aku tak tengok kan. Wajak kau WhatsApp ni. Dia tengok kau dengan WhatsApp tu lebih set. Mungkin 2 monitor.
Kiri kanan dia tengok. Jaga ada visi tu. Kiri kanan kiri. Alhamdulillah.
Kita tengok headset dengan ni pun tak perlu. Kita buat itu saja 2 monitor. Expand. Aku tak macam ni kan. Dia bukan macam ni ada macam ni tu. Ini boleh tanya-tanya lagi.
Terang semula, lost sikit. Okay, alright. Boleh ke kita proceed? Okay, everyone dengar ke? Okay, proceed Doctor. Alright. Okay, tadi just a rough idea about Pima Indians. I think they have some request, one request. Okay, kita trying to, okay. Doktor, cerita sini habis sini. Okay, tak faham sangat tu, cerita sini habis sini maksudnya apa Okay. Okay, alright. Yang ni kita go through balik. Kalau kita boleh lihat dekat saya mungkin tak ni. Okay, saya ada satu soalan berkaitan dengan model summary. Okay, if you look on model summary, where is my model summary? Alright, okay. Let me clear this way. Model summary. Okay, this one. Okay, so there are one request. I think immediately after this kita akan move to MNIS, but it's okay. Almost the same thing. But before move to MNIS, let me explain this one. Okay, let's go together. I think everyone hopefully dah refresh. Okay, so I draw here the network. Okay, so input kita kita semua agree ada 8 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is your input. Based on ada yang umur, ada yang systolic, diastolic punya information. Okay, so the next hidden layer saya ada 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, agree So I have a 12. So bermakna dekat sini, how we get 108 here? 108 here maksudnya ada, saya ada satu connection sambung ke sini, satu connection sambung ke sini, satu connection sambung ke sini, satu connection sambung ke sini. So semua bila sambung kat sini saya akan ada 8. Betul Okay, 8 weight sambung dekat one knot. Okay, kemudian saya ada lagi 8 sambung dekat knot yang kedua. So saya ada yang ketiga sampai yang ke-12. Tambah yang ke-12. So sama dengan 8 kali 12. Jangan saya ambil phone saya tengah charge. Sekejap Ada WhatsApp. Okay. So 8 kali 12 tambah 12 sebab saya ada 12 knot dekat sini. Setiap ni ada bias dia tersendiri. Ni ada bias, ni ada bias. So that's why macam Dr. Atif share dalam WhatsApp, 8 kali 12 campur 8 dapat 108. So the next layer saya ada 1, 2, 3, 4, 5, 6, 7, 8. So setiap ini akan disambung daripada 12 knot yang daripada layer sebelum. So saya ada 12 tambah 12 tambah 12 untuk 8 knot. 12. So saya ada 12 kali 8. Kenapa 12? Sebab 12 from the previous layer kali 8, 8 from the next hidden layer tambah 8 bias sebab saya ada 8 knot. So sama dengan 104. Okay, the last one saya ada 2. Semua ini sambung, saya ada 8 tambah 8 tambah 2 bias. So saya dapat sama dengan 18. So 108 tambah 104 tambah 18 dapat 230. So ini semua adalah total weight yang perlu diupdate setiap kali pergi ke backward. Okay. So hopefully it answer soalan tu. Okay, we can leave the Pima Indian, but somehow I think let's move to MNIS, almost similar. Okay, saya stop kita move to the next one. Saya akan further explain on MNIS after this. Okay, let's move to the website. Okay, can close the Pima. Click collab code. So kita, okay, almost similar. Okay, so again, before you change any code, okay, please make sure file, save a copy in drive. Put your name. In my case, I put PSAS. And then don't forget to file and save. Okay, kalau ada soalan boleh tanya terus Kita cuba habis 5.30 lah. Hopefully kita boleh habis. Okay, so almost similar, but we run on MNIST dataset. So for this MNIST dataset, the difference is our dataset is downloaded from the Google, from the website, and from the network, from the internet. Okay, let's go together. Okay, so this is together with some of the Python code we need to run. Okay, so this is all the network that, the library that we need to have. Okay, please make sure you save first. So kalau tengok dekat sini, kita tak ada mounting sebab data kita ambil daripada internet. So that's the only difference. So kita fix random seed for reproducibility. So that means kita assign a weight randomly, but every time we assign, there's going to be the same value. Okay, next, kita nak download dataset. Okay, so this is where we download. So the dataset is available now. So, okay, just to share, this is where we can plot the first dataset. Okay, this is where you see, that's why I'm interested to share on the MNIST dataset, because you can appreciate, because this is a simple, this is a number, then we can visualize it. Okay, so dekat sini mungkin kita tak cover matplotlib. Siapa biasa, let me share with you what it mean by subplot 2 to 1. At least you can understand. This is mainly for plotting, nothing to do with A and N. So 2 to 1 means I'm going to have 2 row, 2 column. So in the canvas for drawing, saya akan ada 1, 2, 3, 4. So kalau kita tengok kat sini, kita plot yang kosong di sini, plot yang 1 di sini. Okay, so this is kosong. But of course we can check. If I'm wrong, you can correct me after this if you run. So we want to plot somewhere here for the next index. So gambar ni maknanya sebenarnya kalau kita masih ingat, kita ada 60,000 keping gambar. So ini gambar yang pertama. Ini gambar yang kedua. So sekarang ni kita nak plot gambar yang ketiga di ruangan ini. Gambar yang keempat di ruangan ini. So kita nak tengok apa gambar dia. So kita can copy this one. We can do, just simply take from here, plot, Okay, so plot 2 to 1, 2 to 2, 2 to 3. So gambar yang ketiga, 2. Okay, so you can run. So gambar yang ketiga sebenarnya nombor 4. So macam mana kita nak run yang gambar berikutnya yang keempat? Kita boleh copy juga. So 2, 2, 4. So this is subplot. I think those who are familiar with any programming language, hopefully you get some ideas on this one. Okay, but we are filling up element number 4. Okay, what is the number is it? Okay, 5041. So maknanya gambar yang ketiga, gambar yang keempat, indeks ketiga. So hopefully you get an idea. Okay, boleh tanya kalau nak tanya boleh. So indeks dalam dalam array in Python, index dia refer to 0, 1, 2, 3. So this is my array index, the index. So what is my first value here is 5, 0, and 4, and 1. Okay, betul lah. Okay. So kalau kita scroll ke bawah, 5041. So Kalau kita nak tengok dia ada 60,000. So maknanya last kali kat sini adalah nombor 599999. Setuju training? So kita boleh cuba. Katalah kita nak tengok dekat sini nombor 2000. Katalah nombor 20,000. Okay, so which is the 20,001 index. So nombor 20,000, so kita boleh cuba dekat sini. So kita letak 20,000. And then we know what is the index, what is the value or what is the character in index 2000. Okay, this is nothing to do with ANN, but it is very important to develop our understanding towards the end. Nanti kita akan buat testing. How good our model is. Okay, so of course kita boleh cuba yang last kali. Kalau kita cuba 65,000, we anticipate is going to be error, out of index. Okay, it is out of index, bound. 0 with a size of 60,000. So I think the last number is supposed to be, if 60,000 as well, I believe is going to be wrong. Okay, because the last index is supposed to be 59999. Right, so no issue. So the last character, okay, in MNIST on the training data set 5999 in the index 5999 is nombor 8. Okay, what we want to do now, same thing, we want to test on the second image of testing. Okay, boleh follow ke Dr. Atif tanya? Okay, kita tengok yang ni. Dia last kali 10,000 sepatutnya dia run at 99999. Okay, alright. Boleh Ni straightforward je. Ni more on plotting. But they will give some ideas on this one. So maknanya last index kita 9,909, the index item nombor 10,000. So if you put 10,000, hopefully it will give me an error lah. Okay, sebab kita ada 60,000 training, 10,000 on validation later on, we can see. Okay. So to make it right, just to run on, let's say number 1,000. Okay. Okay, so this is my number of 1001. Character is nombor 9. Okay, what we want to do now, you just want to save some value of it. Okay, what we trying to do here, okay, yang dekat sini, you all sambil tu boleh run boleh cuba run. So dekat sini adalah kita nak buat, if you still remember, okay, let me run the code first. Okay, so this is, if you print here, print num classes, num classes, just run. So I have 10 classes, 0 to 9. Oh, okay, let me run again. Okay, I believe it's something wrong with, let me redefine back this one, because I believe we cannot run twice. Alright, so dia punya index tu bertambah because of the same variable. Okay, so make sure if it's failed, we just download again and run immediately this code. Okay, so I have a 10 classes. So what we trying to do here, saya dah mention tadi, cuma saya remind balik. So sebenarnya gambar ni size dia 28 kali 28. So do you get an idea? I have a 28 times 28. Okay, so this 28 times 28, what we trying to do now, kita nak convert dia kepada vector. Okay, column vector. Size of 784 times 1. So, okay, ulang balik Okay, saya refresh balik. Okay. Okay, tak apa. Saya nak mudahkan ni. Saya share dulu. Okay. Now, it's me, my pad. Okay. You can refer back to your hopefully nampak Okay, this is my whiteboard. Okay. So sekarang ni kita punya gambar adalah tadi 28 kali 28. Setuju ya? So this is my, katalah dalam ni nombor 7. So sebenarnya dia adalah 28 pixel. Ada 28 kali 28. So what we want to do, we want to take this pixel from the matrix into a column vector. So 28 kali 28 saya dapat 784 kali 1. So caranya saya ambil yang ni pertama, saya ambil 28 kali 1. Kemudian saya ambil lagi 28 kali 2. Sehinggalah 28 kali 28. So now all these things equivalent to 784. So this is what we want to draw the network. So 784 ini akan menjadi node kita. 1, 2, 3, 4, 5, 6, 784. Okay, so this is my first pixel and this is my, so if I draw my image, okay, so this is my first pixel and this is my last pixel. Get the idea, right? Kalau ada soalan boleh tanya. So the next pixel here, nombor 2. So kalau saya boleh tukar color dia hijau. So this is my second pixel. It's referred to here. Second one. So from the matrix of the image, now I have my vector column. Okay. So then this is roughly the idea. So then you're going to have your hidden layer. And in terms of the output, saya ada 10 kelas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is where it connected here. Okay, so same thing here. And this is your hidden layer. And see how we going to decide our hidden numbers of hidden nodes. On the, okay, hopefully you get some ideas on that one. Kalau ada soalan boleh tanya. Okay. So this is what we're trying to do. And this is what the code trying to do. Vectorize it. Okay, reshape, number of pixel. So this is where you vectorize it. So this is the idea. We want to do some normalization. Dalam ANN or any method of when we trying to quantify the informations, we can introduce a normalization. It means, kalau you all aware, when we have image, our image, if it's a black, I think Amnis is a grayscale image. So the pixel value can range from 0 to 255. All right. Tomorrow I am going to share more on the image of the pixel on the RGB. So, but the index value, I mean the value for grayscale for 8-bit data set for 8-bit system is 0 to 255. So what this trying to do here, x train and x train divide by 255. So you can imagine now, this is my image. So it has some value here. So let's say this first value is 240. So, and if I start to normalize, all my pixel value only range between 0 to 1. So the corresponding value here is equal to 240 divided by 255. So the maximum value can range here between 0 to 1 only. Okay, so 240 divided by 245, I think around, I'm not sure, 0.7. Okay, roughly. Okay. So why this is important? If you have a large value, multiply with a, okay, so simplest way, when we normalize, we want to have the generalization capability in network. Simple as that. Contoh kalau kita ada satu value yang sangat besar, kita kali dengan weight yang kecil, perubahan dia tetap besar. Tapi kalau kita ada pixel value yang kecil, kali dengan apa-apa value, dia akan kecil. So kita nak make sure it can generalize. Say one of the idea of generalizations not only on the hidden nodes, number of hidden nodes, but the information. So that's why if you see a lot of papers, they're trying to normalize. That's why we need to do some image pre-processing earlier before we pass into. But it's not really extensive as when we talk about image processing on the okay, so hopefully give you an idea. So the next code is basically what you're trying to do is this is one hot encoding, OHE, one hot encoding here. So you can prove later on. Okay, let's say if you get the idea, now if I want to add to prove that it is one hot encoding, we can print Y test, for instance. Okay, let's print Y test. Then you will see all are one hot encoding. So this is the first one. I believe kalau kita tengok dekat gambar atas ni, the first one is nombor 5. Nombor 5 kita assume 0, 1, 2, 3, 4, 5. Kita tengok nombor nombor kedua. Okay, so sepatutnya dia tersusun 0, 1, 0. Okay, but we need, this is, this is Y test. If you do on the Y train, then you can see the correlation. So the correlation, kalau kita tengok nombor yang kedua adalah nombor 0. Okay, nombor 0. This is nombor 0. Right? So it's supposed to be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so and then it's equivalent to what you have to expect, this one. Okay. All right, so let's now define our network. Okay, so this is our network. So kalau kita lihat dekat sini, input dim is num of pixel. So we can print, add another code. So kita print dulu, print num pixel. Kalau ada apa-apa soal boleh tanya terus. Saya cuba habis by 5:30 lah. Okay, paling cepat. Sorry. Okay, 6 pixel. 784. Mana dapat 784? Sebab 28 kali 28. So let me give you an idea. Okay. Boleh. Betul saya ada dekat 6 classes. Ulang balik, kena run balik dari atas. Okay. For president, what you need to do, I think as Dr. Atif mentioned, because the redundancy of the use of the variable sebenarnya, tapi just focus to solve the problem. What you can do as simple as go to your line, this one. Okay, president, go to this line, download, just run again. So that is refresh the train dataset. Okay, so then immediately run this line. And then you will see no error because of the redundancy only. Okay, let me complete this one. Okay, then 6 pixel. Okay, so kalau perasan dekat sini adalah kita punya number of hidden node for the first hidden layer. So this is my hidden input nodes. Jenis kernel initializer, maksudnya apa dekat sini? So saya ada weight saya akan didistribute secara normal distribution. So normal distribution means, so you have the value like this one. So let's say your mean value is 0 and it is between, just to share, let's say with the standard deviation of 1. So that means your value can have with this based on distribution, normal distribution. So the occurrences is close to when so you can imagine banyak nombor akan jadi 0.001. Tapi kalau kita buat equal distribution, so katalah saya ada value antara 0 ke 1, so it's fair. So all the time mungkin value akan equally distributed. Kalau saya tadi ada, kalau dalam case kalau dalam case Prima Indian tadi saya ada 230 weight kan, so that's going to be equally distributed in term of the value. Tapi bila normal distribution akan nampak dalam 230 value dalam weight kita. So hopefully you can imagine, sorry, saya harap boleh imagine. So kita ada network, ada 230 tadi tu, kita sambung semua. When kita sambung semua, setiap nilai weight ni, dia akan ada kebarangkalian untuk dapat nilai kosong region dekat sini lebih tinggi. So this is what means by the distribution. Okay. Okay, ni dekat Pima Indian 230 tadi. Kalau kita ingat, kita ada 108, saya nak relate dekat situ. 104, kemudian kita ada 18. Okay, so dalam kes ni nanti kita akan tengok. Kita akan ada banyak sangat. Kita akan ada 784 kali 784 tambah 784. Nanti kita akan dapat value ni instead of 108. Okay, boleh. Okay, let me explain again. Saya cuba gunakan my slide. Okay, saya stop dulu yang ni. Okay, stop sharing. Okay, hopefully everyone follow me. Okay, this is where I want to share on the normal distribution. Okay, this is what it means. It means, okay, kalau kita lihat, okay, let's move our thinking into Pima just now. So our Pima kita ada 1, 2, 3, 4, 5, 6, 7, 8. Setuju? Kemudian kita ada 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 12. So sebenarnya kita nak relate dekat perkataan kernel initializer. Kernel initializer, kernel init. Kernel init ini, kernel init ini, kita look at normal distribution. Okay, kernel init is defined as normal distribution. So kalau dalam kes ini, kita ada, tadi kita dah kira, so kita tak kira lagi, kita ada 96 tambah 12 sama dengan 108. Betul? Okay. So setiap sambungan ni, dia ada nilai weight dia yang tertentu. Contoh W1, ni saya punya W2. So W1 ini, W2 ini, dia akan ada, okay, contohlah saya punya mean value dekat sini kosong, standard deviation saya by 1. So as simple, maknanya the occurrences to have a value of 0, close to 0 is very high here compared to here. So let's say saya tak guna standard deviation, saya just use a value, katakan kosong dekat sini, dekat sini saya punya nilai saya set sebagai 3. Kat sini saya set sebagai negatif 3. So in general, when I have W1, W2, W3, saya ada sampai W8, setuju and W108. Okay, ni setuju So kita ada W1, W2 sampai W108. Most of the time, value dia akan dapat dekat sini. Contoh dia akan jadi 0.01, 0.02. Kat sini 0.05. So hanya certain value saja, mungkin W80 nilai dia jadi 2.7. So bila kita tengok value ni, kita remap balik, bila dia nak initialize, dia akan mematuhi this distribution. So the early value or the weight value of my weight W1 sampai W108 akan mematuhi normal distribution. So this is my normal distribution. So hopefully it answer the question, Okay, let me move to the next one. Oh, salah. Sorry. Okay. Kenapa dia masuk sini balik? Okay. Be patient sikit je lagi ni. Okay, so this is what meant by kernel normalization. So activation function dia adalah ReLU. Okay, ReLU 0 max 0x. And then kita ada again kernel normalization. And then, okay, what is a softmax? So siapa yang lihat tadi, softmax ini adalah, saya ada share sebelum lunch tu. Softmax ni adalah satu activation function untuk address multi-class. Okay, the main part that we makes this problem different from the previous one, for Pima Indian ada dua kelas saja, kosong atau satu. Okay, later on I try to address. Saya sepatutnya tukar the variable. Nanti saya akan tukarkan variable tu. Okay, kita continue yang ni dulu sekejap. Okay, 01. So tadi ada dua kelas. But now kita perlu differentiate 10 classes. So softmax is the idea of we want to solve a multi-class problem. So as simple as, okay, I give you an idea. So what we're going to do here is we're going to have y log y. Okay, mungkin saya boleh shift dulu, saya boleh share a little bit about this one in my screen. Better to share a little bit. Okay, kalau kita tengok dekat sini. Okay, what is a softmax? Softmax, okay, I limit to, let's say, 3 classes. 0, 0, 1, kelas pertama. Apple katakan. Orange, I have 0, 1, 0. Banana, I have 1, 0, 0. Setuju So I have 3 class, example. So if it is more than 2, I need to use softmax. How softmax works? Softmax works as simple as this one. So if I have a y, I just need to have my y log y hat. Right? So for this case, I have j and j and j here. So j, where j refer to number of class. In this case, j equal to 3. So I equal to 1 into 3. All right, so this is the idea. Okay. Okay, I give you an idea. So hopefully you will still remember. Okay. My yj, this is my actual, this is my label, this is my predict. Okay, setuju Predict. Okay, how it works? Very simple. So for instance, for one particular sample, let's say I'm talking about Apple now. So for this particular sample, sample number 1, my label is Apple. So it's supposed to be 0, 0, 1. Setuju? So what happened to this equation? Okay, negative 3, I equal to 1, I equal to 1, yj, j equal to 1, yj log yj hat. Okay, tapi nak mudahkan nanti boleh terus ni lah. Saya ni je terus. Terus masukkan dalam, sorry. Okay, so 1, 0, 0, 0, 0, 0, 1. Okay, sample. So what we can do here now, so I have negative here. So my yj, the first yj is 0. 0 times anything is 0 plus, okay, 0, okay, let's say I just put longer, log yj hat is 0 plus 0 log, okay, this is not yj to make it easy for you to appreciate this one. So this is my y hat 1, 0 log y hat 2 plus, now I have apple. Only Apple have a 1 here. Log y 3 hat. Okay, if you see this term, this is 0, this is 0. How we can make sure, again, error, when we do error, we need to make sure actual equal to predict. So in order for this going to work, so this loss function for softmax, y log y3 hat must be equal to 1. Only that we get this is 0, this is 0, and this is 0. Okay, so what softmax trying to do, softmax inherits binary cross entropy, but they just use a longer term. So then you can extend from 3 class to 1,000 classes. Okay, so this is what softmax trying to do. Right. Okay, let me share. Okay, dah nak 5 setengah. Okay, saya habiskan sedikit. Okay, so this is what softmax, and then you do compile. So categorical cross entropy, it relates to softmax. We need to use categorical because we are dealing with more than 2 classes. So this is our gradient descent, and this is where we want to have the accuracy. So let's try and run. Okay, kalau siapa boleh, and then I try to solve a precedent punya problem. Larger model is not defined, so that means I don't create the model yet. I don't build the model, define the model yet. So click the words, and it's going to train. It takes some time. So now your data set is getting larger and larger. Okay, so okay, boleh. Nanti saya cuba change a little bit on the code. Okay, saya just nak share dekat sini. Kalau kita lihat dekat sini, with this one, so now my not so bad. The model is good. Okay, the accuracy is 99.87. Okay, with this one, and this is my validation accuracy. Okay, what I want to share here. So we plot some performance on the X test. So this is where how good my model is. The model is 98.34. So for MNIST dataset, the benchmarking is 99.7%. 99.7 of accuracy. So now we have 98.34. So tomorrow we're going to look on how CNN can further improve this network. Okay. Nanti saya return back kepada yang ada masalah tu. Okay, apa yang saya nak habiskan dekat sini dulu. Okay, so sekarang ni contohlah saya ada gambar nombor yang ke-251. Indeks dia 250 kan? Tadi saya dah share. So katalah saya pilih gambar yang lain. Saya nak pilih gambar nombor 9000. Okay, gambar 9001 sebenarnya. Gambar indeks 9000. Kita nak tahu apa oh, testing tak ada 9000 rasa. Oh, okay. Let me run this one first. Okay, let me check. Okay, I need to run this one. Strength X test. Okay, it's coming from this problem. Same problem like what you face now. Okay, kita run ni. So, we're going to have this one. Okay, no issue. So, test, same thing, no issue. And then I trying to run on this one. Save this one. Okay. Okay. So, this is why train. Yeah, I will share later on what is the issue. So, hopefully it works. Okay, so because it is not safe as the variable, they referring to the earlier variable. Okay, so I think now if X test change to 9,000 is going to work, supposed to be. Okay, okay. Let me finish first, and then we're going to debug everyone's problem. Okay, so okay, nombor 9,000 ni adalah nombor 7. So kita nak tunjuk how good it is. So dekat sini saya just perlukan 9,000. So gambar yang sama tadi kita dah tahu ini adalah nombor 7. So this is how it work. So bila kita predict kelas ini, so sepatutnya dia akan predict nombor 7. So this is number 7. So katalah saya run, kita boleh cuba dari satu perspektif yang lain. Kita run nombor 2,000. Kita tengok dia predict berapa. Now dia predict 6. Betul ke 6? So I can plot again nombor 2,000. So sepatutnya dia akan keluar nombor 6. Betul kan? Okay, so once again, katalah saya predict nombor 33. Index yang ke-33. Dia predict nombor 4. So we expect it's supposed to be nombor 4 with the confidence level of 98.34%. So that's mean if I put number 33 here, at very high chances of 98.5% is going to be number 4. Right? So this is number 4. So this is how it works. Let's run all the code. Siapa yang ada masalah, just let me know. Kita trying to debug together. So the easiest way, maybe I can share with you. Okay. Okay, cuba run dulu semua orang untuk MNIST dataset. Okay, saya cuba solve masalah presiden tadi. Mungkin boleh share ke kalau presiden nak share on the screen? Okay, kalau Dr. Wan boleh share apa isu dia sebenarnya tadi. Tapi paling senang sebenarnya kita tukar je variable ni. Xtrain, Xtest, Ytest. So, this is my Xtest. Okay, so this is the one I would suggest to do. I can have as simple as this one. Okay, President. Okay, kita cuba debug katalah kita go up. Okay, so my suggestion what you can do here, let's print. Kita tengok sebenarnya. So, ingat idea kita, whatever we trying to do, kita kena bear in mind, whatever code kita trying to do, kita nak tukar 28 kali 28 ini kepada 784. That's our idea. 784 times 1. Okay, that's the main objective. So what we can do here, let's have a look. And boleh cuba print, kita tengok apa sebenarnya size dia. It's already 784. That's why I think, okay, if I run again, kita tengok kalau saya print test shape 2, it's going to be, okay. That's the problem. Dia akan, that's why dia, okay, kita tengok. This is more on the code, nanti. Okay. Okay, error, right? Okay, let's run again. Okay, kita cuba download. Okay, nanti kita akan betulkan variable ni supaya nak mudahkan semua orang. Okay, this is just a plotting. So if you keep this one, and this is where, see, because when you run this for the first time, my Xtrain here dah bertukar menjadi nilai Xtrain yang telah diperbarui. Okay, so kalau kita tengok dekat sini, Xtrain dah simpan nilai-nilai baru. Okay, because of because of this reshape and everything. So to make it simple, okay, let's try. So kita run dulu. So now Xtrain I don't run this one this code yet. So because kalau kita tengok dekat sini, kalau saya run balik saya tengok dekat sini, my X train now, okay, we can have a look. My X train, because dia dah reshape, and then kita akan lihat, saya run dulu yang ni. So you see it is 28 times 28 because we reutilize again. It's going to be fine, but now it's a 784, right? So the problem is because of this assignment of the X train. Okay, so what we can do here, okay, before I move, okay, just download again. Okay, what we can do here, I just make sure I use a different X train. So let's say I call this is as X train 1. Okay, I keep the X train as X train. So X test 1. So X train 1, X train 1, X train test 1, X test 1. So Y train, it should be no issue. Okay, and then when we want to pass the network, we need to pass X train 1, X test 1. Okay, so let's try. Sepatutnya dah tak ada masalah. Y train should be okay. Okay. If you run again and again, sepatutnya lepas ni tak ada masalah dah patutnya. It's more on the variable definitions. Okay, this is on the plotting. And this is where I want to use for plotting. And this is again 28 times 28. So now if I print my X train and compare with my X train 1, one will print 784 and one will print 28. So this is my 28, this is my 784. Okay, so now you can run. Okay, I just want to make it short. I can try to just make it 2. So 2 epoch saja. This is where we have the incremental learning. So now we can see the performance of this. Okay, let's have a look. Larger model, evaluation. So I need to pass what? X test 1. Okay, 97.26. Okay, boleh ke run President now? Kalau ada masalah tu just copy my code. Tukar yang dekat sini saja. Jadikan dia X train 1, X test 1, 2 tempat. Okay, I go with you. So tukar yang ini, X train 1, X test 1, and then you can run again and again. Next, what you need to change here, X train 1, X test 1 as a validation data set. Okay, please follow me. And the last one, if you want to check on the model evaluations, we need to change on the validation with X test 1. And then you can run again and again without any error, supposed to be. Boleh ke? Okay, kita cuba semua orang. Okay, let's try to finish by 6 now. I'm not going to extend more. Semua orang dah penat saya rasa. Okay, ada soalan ke? Saya cuba tengok dekat chat kalau ada apa-apa soalan. Yeah. Okay, so in any machine, hopefully I think I remember my first week of digital electronics. We have what we call a pseudo random. One of the easiest way we use XOR gate, okay, and return, and then you can define different machine will have a different seeds. But again, if you run again and again, what I want to share here, your pseudo random will be similar all the time with the same machine. But your machine and my machine and the other machine, your pseudo random will start with different seed. Even though we assign with the same number on 7 just now, but your machine have your own randomness. Okay, hopefully it answer you this one. Okay, ada soalan ke? I give like 3 minutes for you to test on this one.
Ada soalan tu dah, Doctor. In terms of baseline error and accuracy, If the error and accuracy is different, is it because of the spec of the PC?
Nah, because of the randomness of the randomness of initialization. That's all. It can say a different machine. Betul Dr. Atif? Ada soalan lain ke? So hopefully everyone, okay. So the idea, you can imagine now how good is ENN. So in predicting the numbers, when we start tomorrow with CNN, you can imagine it is even better than this one. So tomorrow we're going to use NVIDIA platform. Okay. So we bring a similar concept on classifications, but we're going to use a digit. Okay, another platform by NVIDIA. But again, the framework is no longer a TensorFlow. We're going to have a look again on classification using Cafe framework, where tomorrow we're going to use Cafe mainly, but all are written in Python. That's the common thing. So, boleh share ke kalau ada masalah lagi, Presiden ataupun Dr. Wan? It is mainly on the variable, I think just now. Okay, what I want to share here is you can try and practice on your own and trying to solve the iris dataset problem. Okay, good to go, eh? Okay, all right. So that's the main idea of today class. So what we're going, okay, I have a question, I think. Ada soalan. How to import custom datasets, right? Okay, how to import custom dataset. Oh, as simple as this one. For the custom dataset, okay, I share with you. For instance, let's say this is my folder. Nampak kan? So saya rasa. So I have a student. So as simple as on where is my teaching AI, training AI module. So this is where my data set. So as simple as this is module CNN. Collab data. So I just need to put it here, data dog and cats. So this is on my data set here. So I need to make sure my data set is in one particular folder. Okay. For data dog and cats. So I need to have my train and validation. So this is where you need to save into a multi-hierarchy of the dataset, and then you can just easily call the dataset. Okay, so hopefully, I think the details, Zuan, I will share tomorrow when I start to share on the CNN on the details. So you can have any dataset, and you need to save everything into the multi-hierarchical of the dataset. So for instance, like this one, I just put into data dog and cats, and then I need to have this all dataset to be all dogs in this dataset on this folder. So then you can call the dataset for being used for the training, right? So I think I can give some ideas on this one. You want to have a look? I have one example just to share. Hold on. So this is my CNN part 2. Today I have the specific slide on this one, but otherwise I need to open. Okay, mungkin tak ada dekat sini. Okay, I need to share on my code. So let me share with you on this one. So for instance, if I move,
Dr.
let's say,
Ibrahim ada share screen ke sekarang?
ada. Saya tengah buka jap saya tengah buka satu file. Okay, so this is one of the idea. We can hold on. I want to do what? Okay, got it. Okay, so this is one of the idea where you can use your data set. So this is one of the image where you import. So we need to have our code like this one. I'm planning to share tomorrow morning, but it's already have a questions by the facilitator, I believe. So cats and dog filtered. So this is where I need to put into cats and dog and validations. So you need to initialization the path, just similar like what we did earlier. So let's see how we passing the network. Okay, so where we call, so this is where I my train data dir. Okay, and this is my directory. So in case, so that's mean here I need to define train data dir. Okay, dir equal to all my paths. So in my case, my docs is on I think let me check. I think the best part I can do here is on my collab data. So I'm going to have my content, drive, my drive. Okay, let's say I have all these things. I can check again. Collab data. Okay, collab data. And then what I need to have is collab data, data.cat, collab data.cat. Collect data, data.cat, data.cat. Okay, data.cat. And of course, I need to have the string. So this is the idea. So same thing for validation. So when I need to call again this data, this directory into my training directory. So I'm planning to share all these things in detail tomorrow when I start on CNN. Hopefully, you can trying to have all this information and where you can have your own data set to be trained tomorrow. But again, using digit, I try to spend a little bit short time on using Keras TensorFlow here on where you can use your own data set. Okay, so that's the main idea. So hopefully it answers some of the questions. Okay, ada soalan lain?
Okay, thank you very much, Dr. Ibrahim. I believe we have learned the theoretical part, and then we have tests with two database, and hopefully we can have rough idea on how ENN will work. And tomorrow we're going to compare with another algorithm, CNN, and we can see the comparison and what Lanshan was asking regarding the directory, replacement of directory. Just now, Dr. Ibrahim showed us. We can do that later tomorrow. So we can adjourn this session.
Tolong letak, boleh tak saya kacau sekejap?
Boleh.
So I think let's try. If you, I think early in the morning, I share on Iris dataset. So let's solve the Iris dataset by your own. So if you are interested, you can try and solve your problem. I just give a hint. The problem of this particular dataset, okay, just to share with you. Okay, I try to take maximum 5 minutes, not more than that. Okay, if you see on the versicolor, so the real problem of this one, okay, your label is not an integer. Your label is a text. Okay. So you can design your own network where the output of the where the output is 3 classes. So you need to have three classes with a one hot encoding 001, 010, 100 for that particular reason. So hopefully you can try on the iris dataset. I just want to share the last part on the iris. I think if I can have here collect data, I have the iris. Okay, wait. Yeah, I just want to share how the dataset look like. Okay, now I share on the screen. Okay, so if you see here, I have the iris already shared with you. So let's open the iris, how it looks like. So iris dataset, you have, so at least you can figure out. So I have first feature, second feature, third feature, fourth feature. So you can determine how many nodes you need to have in your input layer. And on top of that, you see I have iris setosa, iris versicolor, and the other class. So in total we have 3 class. So but again, the challenging part is more on the Python code, where your level is not a number. Like Pima Indian, you have 0 and 1. For MNIST dataset, you have 0, 1, 2, 3, 4 until 9. So you need to change this one into 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. But for this particular case, you have a 3 class, Setosa, versicolor, and the other class, let's say M, forgot the name, the other one. So S you need to represent as 100, V you need to represent as 010, and the last one you're going to have 001. All right, I think if you want to try, feel free to try the iris dataset, create your own network and do your predictions. But my final word on today, how you can create new file, you just click file, new notebook. This is I don't share yet. So if you want to solve, you can create file. Just now I shared to you. Go to your file, new notebook. Okay, then you have all your environments available. And then don't forget to save. So call is iris PSSS, whatever you can put your name, and then file save, and it's appeared into. So you can copy all the existing code, no problem, but you need to customize on your own. I think that's all from me, Dr. Latif. Thank you. Yeah. Okay, Zuan, what is your questions? Okay, good question. When we talk about ANN, I would say it's like a black box. Why it's have come across with a black box idea? Because we cannot answer the problem just now. How many layers? How many hidden nodes? And on top of that, we do not know what's really the weight value. We cannot interpret the weight value at all. But when we start to move into CNN tomorrow, and then you will start to realize all the filter design come with the weight value. The weight value you can do some interpretation, where when you see on the CNN later on, the image will be have some excitement on the important region when they want to predict. So in my perspective, in my point of view, ANN, there is a lot of ambiguity, where some of the weight the weight itself, it cannot be interpreted. But when we move to CNN tomorrow, we will see all the filters or the weight filters. Somehow we can interpret it. So it's moved to some called like a gray area. So some part of the CNN, it works to be interpreted, but ANN, the weight doesn't give any value. Right? Okay, hopefully it answered the question. Thank you. Okay, I think that's all, Dr. Latif.
All right. Okay. Somebody asked me whether the session tomorrow will be from home So I believe that if the condition today is good for everybody, then you can be at home, but then we have to make it online as today. So we are going to give you the link. I think we're going to use the same link, right, Dr. Ibrahim?
Okay, I will share to somehow tonight or early in the morning tomorrow. We're going to register first in NVIDIA development website.
Yeah.
Please make sure you use the Gmail address, Gmail account that you share with me this morning.
Okay, all right. Okay, so then we're going to meet tomorrow. Thank you again, Dr. Ibrahim. And we have the group to be on. So if you have any question, you can ask there. And you can still run some of the codes. So yeah, let's be in touch. So thank you again for your contribution, attention, as well as the commitment. So we're going to continue tomorrow. I think that's all. Thank you. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Um,
Waalaikumsalam.